So I think we can start right now. I hope everyone can hear my voice clearly. Sometimes the internet might be uh, a bit slow, so I might sound like a robot. So if my voice goes completely off, please drop a chat and tell me. So I would like to wish a good evening to everyone. Today we are going to talk about this exciting topic on machine learning with BigQuery. BigQuery has been evolving for a long time now, and it has come to a state where BigQuery is kind of like a very core component in the Google Cloud Platform, because we now use BigQuery for data analytics, machine learning, data visualizations, for data pipelines, and as for streaming data, for batch data analysis. So BigQuery has been evolving pretty much, and it has some cool stuff that that we can do easily. So my name is Raveen. I currently work at LSEG Technology as a senior software engineer, and I'm organized at GDG Sri Lanka as well. Right. So when we talk about the Google Cloud Platform, there are many ways that you can do machine learning. So one way that we can do machine learning is by building custom ML models that will include the Cloud Data Proc, Cloud AI platform, and BigQuery as well. So these kind of things let us build custom ML models and deploy them on the Google Cloud Platform for our data analytics and machine learning workloads. And there is also something called AutoML that Google has recently introduced. AutoML lets users to build custom ML models, but without writing any code. So you give your data set to the Google Cloud Platform, AutoML, and AutoML will task that you want to do, and without you running any amount of code. And the other part is machine learning APIs, which have pre-trained models. So these aren't custom machine learning models. These are pre-trained, and you can't do any customizations on top of these. For an example, if you take the Google Vision API, you can integrate the Vision API into your application and call the APIs and get a result out. So these are pre-trained models that the Google Cloud Platform has that you can use in your applications by calling its APIs. Right, so now let's go to BigQuery and see what BigQuery has to offer. So BigQuery is a modern data warehouse. By data warehouse, I mean we store data as we store organized data in data warehouses. Data lakes contain raw data that we haven't done any pre-processing on that. We haven't structured that data, but in a data warehouse, what we have is structured data, right? It can be in tables, in rows and columns. It's pretty much structured, and it's ready for analytics. And BigQuery is in petabyte scale, right? BigQuery can handle many amounts of data, and it's serverless. That means you don't have to manage clusters, you don't have to manage machines or anything. BigQuery handles all the hardware requirements for you. So it runs as a service, and you don't have to worry about spawning new instances of BigQuery. You don't have to worry about increasing memory or anything. BigQuery handles everything by itself. And the best part is it uses standard ANSI SQL. So you can write everything in BigQuery in SQL. That means whatever you have written in MySQL when you're doing your database programming, you can write that same stuff in BigQuery, but with additional stuff that BigQuery offers. For an example, BigQuery offers many functions for, let's say, geolocations, getting time, and there are you can deploy Jupyter notebooks and call BigQuery magic functions. So BigQuery offers so many things for you to carry on your data analytics work. And another great part is you can visualize your data through Data Studio. So Data Studio is a service that is offered from BigQuery that you can visualize your data in many ways, like in bar charts, pie charts, like a time series analysis. You can do your analytic work in Data Studio within BigQuery. And also what we'll be discussing today is how we do machine learning just by writing some SQL statements, right? So we won't be writing any Python code. We won't be pre-processing our data with Python's pandas or anything. We'll just use raw SQL that we know from from our database programming, and try to create models, machine learning models, and train them out of that. Right, so before we go into BigQuery and its console, we have to keep in mind about the BigQuery pricing, right? So if someone asks if BigQuery is free, it's a yes and no answer, because BigQuery has a free layer, but if you want to go further, you need to pay. So to use BigQuery, you need to have a service account activated in your Google Cloud Platform. But if you're signing into the Google console, the Google Cloud Console from a new Google account, you will get $300 of free credit to try everything out in the Google Cloud Platform. So you can use your 300 credits to try things out. So if you talk about the storage in BigQuery, you will get the first 10 gigabyte per month free to use. That means if you are storing any data in BigQuery itself, you will get 10 GB per month free. So this will include models and training data. If you write a SQL query and if you are storing your data permanently or temporarily in your BigQuery, you will get the first 10 gigabyte per month free. And if you're doing analysis, that this will include running select queries, running models. You will get the first terabyte of query data free, and per terabyte that is exceeding that, you will have to pay $5, right? So we have to keep in mind how many data are we going to process with BigQuery, because if you are running in a free tier and if you don't have the $300 credit limit, $300 credits for you, you will be running into some kind of trouble because you will be cost. And the create model statement is what actually creates the machine learning model. These things and what we are going to do here might be confusing to you, but once we go into BigQuery web UI, these will be pretty much clear to you. So when you do a create model statement in BigQuery, the first 10 gigabytes processed by queries for the create model statement per month is free, and for exceeding that, you will have to pay $250 per terabyte. So keep in mind on these numbers, because sometimes you might leave something running on for a long time, and this has happened to some people I know as well. So you might not be getting any so after the end of the month, you'll be getting the bill, and then you will realize that you have been spawning these instances. Right. So what we'll talk about today, the agenda for today is we'll cover BigQuery basics. We'll cover BigQuery machine learning. We'll cover how you import data to BigQuery, pre-processing that data, and do a multi-class classification on a model that we have trained. And we won't be covering advanced BigQuery stuff, because BigQuery is into that if we are going 1 hour. We won't be going into advanced machine learning concepts, and we won't be covering any internals of machine learning models as well. So if you have participated in the last week's session, you might have got an idea on how neural networks and machine learning work. So we won't be covering those stuff today. We'll be focusing on BigQuery and some basics in machine learning. Right. So with that said, we'll go to the BigQuery UI and see what it has to offer. Right. So in my screen, you can see the BigQuery UI. So to get to this UI, you have to go to console.cloud.google.com, and it will open up your Google Cloud Console. So if you're a new user, you will get $300 of credit free to try everything out in Google Cloud Platform. And because we'll be keeping in mind on our free tier. So even I am logged in a new account. So I have my $300. Go to the navigation panel. And when you scroll down, under big data, you can see the BigQuery tab right here. So when you click that, you can come into the BigQuery console. So this is the BigQuery web UI, and it has some options that you can try out. So this is the query editor. You can write any SQL query here, and you can create data sets by clicking here, and you can explore data sets from here as well. So one cool thing about BigQuery is BigQuery lets you import data from many different places. You can import data from your Google Sheets. You can import data from your Google Drive. You can import data from your local machine. You can browse through public data sets that BigQuery has offered to you. And you can also import data from the Google storage buckets as well. So one cool thing about BigQuery is the public data sets that is available for you to try out. So if you go to this add data button, and when you click that, you can see something called explore public data sets. So when you click that, So when you click that, you can see all the public data sets available from BigQuery. And recently they have added the COVID-19 public data sets as well. So you can use these data to try out many different things. So let's search something out from this. I'll get. So there is something called Hacker News dataset that we can use. And when you click on public datasets, it will show up here as BigQuery public data. And if you click it, you can see that it expands like this. So when you click each and everything, so this is a data set, and when you click that, this is a table, and this table will contain data that you need. And when you click on something, so we have clicked on Chicago taxi trips. So in the taxi trips table, you can see the schema here, and you can see other details about that, and you can even do a preview of data. So you can see that there's a unique key, a taxi ID, a trip start and end. So you can use these data for your analytics. So this acts like a normal SQL table, normal RDBMS table. And you can even write SQL queries here to query data. And let's see, I'm gonna, so I've shown you the Hacker News one. So I've copy pasted something from here. So I'll just do a little formatting for you to see what's happening here. So I hope everyone can see the console clearly. So what I'm going to do is I'm going to select the URL and the title from the BigQuery public dataset Hacker News Stories table. So if I search here for Hacker News, so I can see the Hacker News dataset. And if I click on the stories table, right? So if I click on the stories table, I can see that there are some news and some text. So what I'm going to do with this SQL query is I'm going to select the URL and the title of all the news articles in Hacker News stories table. And I'm going to filter out where the title is more than 10 characters long, and I'm gonna ignore all the URLs that are empty. So URL should have something larger than 0, and the title should be larger than 10 as well. So when you write an SQL query like this, you might be wondering how much data I'm processing here and how much BigQuery will be billing me. Right, so if you can remember the first 10 gigabytes for your queries. So for your analysis, you have 1 terabyte. So the first 1 terabyte of data for your analysis is free. And for you to know how much data this is going to process, you can see in this valid query banner at the end, you will see that this query will process 204.8 MB when run. That means this select query will process this much data when run, right? So to keep in mind when you're writing select queries, don't do a select all statement. It will get all the data and it will increase this amount. Just select what you need and do a where to limit the data as well. And when you're writing a limit statement, this limit statement will not affect how much data the BigQuery SQL statement will process. Only what will affect is the selected columns, and when you're doing a where clause, that means you're filtering out data, but the limit is only there for showing only. So if I do a select all here, right, it will show 402 MB when run. So the amount is almost double, right? So don't do select all every time. Just select the things that you want to query and run it, right? So I'm selecting the URL and the title, and I'm filtering out results where the title is more than 10 characters and the URL is more than 0. So I'm going to run this with this run button. Right. So when the query is run, you can see the results over here, and you can see the row IDs, the URL and the title. So all these have URLs, and the title is more than 10 characters long. So the title, there is no title that is more than 10 characters short, right? So you can also see that the query completed with 0.3 seconds elapsed and 204 MB processed as well. So now I want to save this query data as a table in my project. So I don't want to query the BigQuery public dataset every time, right? So this is my project name. If you go to the left side, you can see your project name here, and you can save this query, the results from this query inside your project as a table. So for that, first we need to create a data set. So these are news articles. So I'm gonna save this data set as news articles. Right, so another important thing you have to remember is if you are getting these news articles from if the Hacker News dataset belongs to a European region, you have to set your data location to a European region as well because of the new European data policies. So for now, I'll just select the European Union as the region, and we'll create the dataset. So what I have now here is an empty dataset. I have nothing in that. So now I can create tables inside this dataset, right? So first thing I'm going to do is so I ran the query. Then I'll click this Save Results button, and I can select how I am going to save my results. So I can save my results in a BigQuery table from this drop down. I'll select the BigQuery table, and it shows me that I only have my news articles data set, and under that data set, I'll create a new table called so my new table name is news, and I'm going to save that. So there was an error. Okay, we'll try that again. I think there is something wrong here. We'll try to create a table inside this. Okay, I think the region was the problem. I've selected European region, so I'm just gonna delete this data set. So under my news dataset, I have a news table which has saved the result from this query, right? So if I click on that, I can see the details, the preview of everything. So it's just SQL stuff, right? And what we are going to do with machine learning here is we're going to explore next. So as I've told you before, we are not going to cover concepts in machine learning that deep. So just keep in mind of what machine learning does. Machine learning is everywhere. And if you're going to define what machine learning is the science of programming computers so they can learn from data. And with these trained models, they can be used to provide insights into data for analytics and to get predictions. So we can see machine learning everywhere, right? In our phones, in our computers, everywhere we go, we now have machine learning used for businesses and for marketing. And if you go to Netflix, when you see Netflix recommendations, that is machine learning. You go to YouTube recommendations, and if you go to your Facebook feed, you will have facial recognition, which has machine learning now. And it has been evolving very much now. And we now have deep learning as well, and many machine learning practices that people use for many different applications. So if we get a very high level model of what machine learning does is we basically have a training data set, and we feed that training data set into a learning algorithm, and we tell that learning algorithm that this is the result that I want, and the algorithm will tell, okay, we have an error for that result, so I'm going to minimize that error through iterations. So we go on iterations, minimizing the error of the predicted result against the actual one. And this phase is called training your machine learning model, right? So after that, after the training is done, you will get an improved model, which when you feed on new data, it will pump out the prediction that we need to do. So this is a very high level model of machine learning. More specifically, this is a a supervised machine learning problem, which we already have a training set with the actual and the predicted result. So there are many machine learning models and practices, but BigQuery is still evolving in machine learning, and we have to know what kind of models BigQuery provides for us to do our machine learning stuff. So BigQuery currently have linear regression, which we use to do predictions on continuous data. And for discrete data, for doing classifications, we have binary logistic regression, multi-class logistic regression. And for unsupervised learning, we have k-means clustering supported. And also, if you have your own custom TensorFlow models, you can import them to BigQuery and run predictions on top of it, and run training as well. And if you are building recommender models, say for an example, you are building a model to recommend movies or products to customers, it uses a method called matrix factorization. And in BigQuery, matrix factorization is only available to people who have a fixed plan, because it's not in the free tier, and you cannot use it in on-demand scale as well. So matrix factorization is there for people who have a fixed plan. And for deep neural networks, we have DNN classifiers in the alpha stage. So this will be improved in later versions of BigQuery ML. So these are the models that you can, various different models that you can use in BigQuery to do your machine learning. Right. So before we do anything, before we do our machine learning stuff in BigQuery, we'll get an idea about how the machine learning flow happens. So first, you need to have a data set. You have to prepare your data set. Next, you will use a query called create model. That can be create or replace model as well. So you give your model a name and you give it out some options, right? You can specify the model type as linear regression, logistic regression, a deep neural network, a k-means one, and then you have another query called select that you need to specify your data for when you're feeding your model some data inside. When you're feeding data into your model, you have to give all those things in this select query. So we will go to an example, and you can understand this more. And this create or replace model does your training, but to do the evaluation, you have to, after the training is done, you have to do the evaluation of your model, and you can get some metadata out of your machine learning model to see how well it has been trained and see if it's a good to use model. And finally, you can do predictions, right? So you can feed in new data inside your model, your trained and saved model, and you can get out predictions as well. Right. So we've talked about the public datasets that BigQuery offers, but now what we are going to do now is we are going to import the iris dataset to our BigQuery ML, and to try to predict if a class, if our flower, if our iris flower contains in any of these classes, right? So what our data looks like is a column, it's a raw column format like this, like a table. You have the sepal length, sepal width, petal length, and petal width of the flowers, and you have a class. This class will be either iris setosa, iris versicolor, or iris virginica, right? So depending on these values, we are going to try to predict whether given a new data, to which class this data would belong to, right? So to do that, we are going to use a method called logistic regression. So logistic regression is a machine learning method that we use as a supervised learning method, and we use it for classification problems. It can be binary classification or multi-class as well. So binary classification means you are either predicting 1 or 0. That means if you are predicting positive or negative uh, classes, it's a binary classification. But if you're doing more than two, if you are trying to predict more than two classes, you have to do a multi-class classification. So logistic regression used as a one versus all model provides us with the capability to use the logistic regression as a multi-class classifier. So if we look at this, at a very abstract level, what we are going to do here is, given a new data set like this, right? We'll have a sepal length, sepal width, a petal length, and a petal width. Given these data, and if we feed that into our trained machine learning models, we need to predict if these properties belong to which of these classes, right? So that's what we are going to do now. So we'll dive into the BigQuery demo and continue with the model creating and the predictions. So I'm gonna remove this, and I'm going to show you how to import data into BigQuery. So I'm going to click my project here. I'm going to create a new data set. So the data set name would be iris. So I'm going to leave everything as default values. So if you can see here, my iris data set has been created. It has nothing in it. Now I'm going to import my iris data here. So if you look at what the iris data looks like, I hope you guys can see this. This is a CSV file that has all the iris data included. So you have different values with comma separated and the class of that flower. So all these are iris setosa. And if you can see here, you have the iris versicolor ones. And at last you have the iris virginica ones, right? So I'm going to import this data to my BigQuery to be used as a table. So I'm going to click my data set and I'm going to click create table. So the create table will open up the create table window. So for the source of the table to be created from, I'm going to set it as upload. You can see that there are many other options as well. And I'm going to select my file. So this is my file, iris data, and the format is CSV. So I'm going to select CSV here. And my data set name is iris, and my table name, I'll give it as iris underscore table. Right. So if you can see the iris data set here, we don't have a header column, right? So how BigQuery is going to recognize these columns, right? So BigQuery has no way to recognize what should I name these columns. So because of that, you can edit the schema and give it fields as headers to BigQuery to understand it. So I'm gonna, so this data contains like this. So this is the sepal length, this is the sepal width, and this is the petal length, and this is the petal width, and this is the class. So I'm gonna give those columns here. So it's a float. Then I'm gonna give the width as a float. Next, the petal length. Then I'm gonna give the petal width. Next, I'm going to give this class. So I will give something like this, and the class is a string, as you saw in the CSV file. So after specifying those things, I'm going to create this table. So it will take a little time to create this table. And it says that my table has some errors. Let's see. So error while reading the data. Right. So let's see. So this might be because of some new lines that this data has. So I'm going to open this. Right. So finally, the iris table is now created, and you can see some metadata of the table. The table size is 4.93 kilobytes. There are 150 number of rows, and if you go to the preview, you can see this table nicely as a SQL table. You have the sepal length, width, petal length and width, and the type. So I'm gonna show you this cool feature in BigQuery, right? You can view this data visually in Data Studio. So I'm gonna show you how you can do that. So I'm gonna select all from my iris table. right? So this will show that my query will process 6.9 kilobytes. So it's a really, really small amount. So I'm going to run this. So after I ran this result, I can see the result. But the cool thing is you can click in this Explore Data tab, and you can explore this data with Data Studio. So Data Studio provides us a very cool way in BigQuery to view your data in charts, in pie charts, in bar charts, and in time series as well. So for now, this has a table here, so I can add charts here. So I'll just change this table to a pie chart. So you can see it's pretty much easy to do this thing in Data Studio. Now you can see that for each class, I have 50 data each for my 150 data for the 3 classes. And you can play around with all the stuff in here. Now I can add a column chart here, and I can add new matrices. Let's compare the petal length and the petal width of all the classes of the class. We'll just remove the record count from here. Right. So now with this bar chart, I can compare the petal length and the width of each flower class. So you can see that Iris virginica has the most high value of the petal width, sorry, petal length, and the others have small ones. Right. So we'll go back to BigQuery. What we are going to do now is we're going to create a logistic regression model so that given a new row of data to our logistic regression model, we can get a prediction now, right? So this is how we're going to create a model. So I'm going to write this syntax: create or replace model. And I have to specify a name for my model. So I'm going to create this model under my Iris dataset and give it a new name called Iris underscore model. So now I specify the options that I'm going to use. So first I have to say what are the input label column is. So my input label column is called C type, which is this one. What this means is when we are doing classification problem, this is what we are trying to classify our data into. So our column name is C underscore type. And we have to specify our model type. So my model type is logistic regression. For that, I have to write logistic reg here. Right. So now I have to feed in data to my model, right? So from this syntax, I have created my model and specified the output value, what the classification value should be, and the model type to this. To do that, I'm going to write a select query. I'm going to select the sepal length, sepal width, petal length, petal width, and the class type from my imported iris table, right? So I'm going to write from my iris table, right? So if you see the query here, I have created a model and feed in data from this select query, right? So I remember that we only have 10 gigabytes of create model statement that we can do per month. So if you can see at the right corner here, it will tell you that this query will process only 6.9 kilobytes, right? So for a simple task like this, BigQuery, uh, you know, you know, you don't have to even have a free 300 credit account for this, right? It's just really small. So now I have created a statement to train and uh, train my model, to create and train my model. So I will run this query. So it's going to take some time. And if you can see here, we are still in the pre-process stage. And you can see that the query is running for this much of a second. So it's still running, and now the stage has changed to train. So we can see now that we are in a training stage. And if you have any questions until now, until we get this training done, you can ask them in the chat if you want. If you want to show me something else here, you can ask any question in the chat as well. Okay, so our model has been trained successfully, and we can see that the iris model is now available under the iris dataset. Now, the cool thing is when you click the iris model, you can see all the metadata about our machine learning model, right? You can see how many iterations has been run. And when you click on the training tab, you can see how the cost is being reduced, how your loss function looks like, and what's the duration of for each iteration. And you can see how the learning rate has changed over time for each iteration as well. And if you click the evaluation tab, you can see all the values for your confusion matrix. You can see, and if you go scroll down, you can see the confusion matrix here. And Iris Setosa has been very good. It has 100% accuracy, and we have the other two as 94% and 98% respectively. Right. So you can see the labels of this model. So the features are the length, width of the sepal, and the length, width of the petal. And the label which it has outputted is the predicted class type of that flower. Right. So now we have trained the model. What we are going to do now is to run a prediction and see, right? So I have a query copied here, I think. Yes. Right. So this is how we are going to do a prediction on a trained model. right? So our logistic regression model is saved as iris model. We are going to try to predict from the iris model given these values, right? So 2.5 as the sepal length, 4.5 as the sepal width, 6.7 as the petal length, and 4.9 as the petal width. So we are now going to try to do a prediction from our trained model. So let's run that. And at the bottom, you can see this really nice table of your predicted values. So our model has predicted that the value that I have given is iris virginica with a confidence of 0.99 of accuracy. That this is a really good accuracy, right? So if you see the other two ones, they have 10 to the power minus 7 and 10 to the power minus 9 probabilities. So we can remove those. And when you do this select query, you can just select the predicted type here only without defining the all and get out the result as well. So that is how you do a prediction on BigQuery machine learning. So you can try out many other stuff from BigQuery using BigQuery public datasets, but keep in mind to count how many rows there are by viewing the metadata of the table. Because if you go beyond the 10 gigabyte amount or the 1 terabyte amounts that you have for your free tier, you might be your service account might cost a lot, right? So keep in mind on what you're doing. When you write a SQL query, every time you have to look at the right side on how much it will process when you run that query. And if you go to the BigQuery, let me show you here, right? So this is the BigQuery page. So this is the BigQuery page for the create model statement. And as you can see, there are create model, the create model statement has many options that you can specify, right? So you can specify the model type as in a regression that we have done the logistic regression one. You can say k-means, or you can import TensorFlow, or you can do matrix factorization. And if you want to optimize this with a an advanced optimization method, you can use batch gradient descent. And if you want to do regularization, if your data is overfitting, you can use regularizations in level 1 and level 2, and you can specify how many max iterations that you have to run. And there are many options that you can customize your machine learning model from here, right? So just keep a look at this, take a look at this page and understand how much customizations that you can do to your model. So I think it's 9.5, and there was another example that I want to show you on the Hacker News classification. I think we will not have time to do that. It's a bit more complex query than this. Might be some other time we can continue to more advanced stuff in BigQuery and what we can do. So that's what I have to. That's all I have to talk about today. And if you have any questions, you can ask them in the chat right now. And I think you can. I think you can also. I don't think you can speak from the microphone.
No, they can unmute themselves and speak.
All right. Okay. So if you have any questions, you can unmute the microphone and ask, or you can ask them in the chat as well. Right. So I think we don't have any questions now. So we'll send you a feedback form for you to fill, and you can give. Okay, so we have a question dropped in right now. Can BigQuery support TensorFlow deep learning models with Adam optimization? It was not there in the supported optimizers list. When you import TensorFlow models, what BigQuery will do is it will just import that model. So if you have specified the Adam optimizer inside the TensorFlow model, you don't have to change it from BigQuery, right? So what BigQuery does is it will feed in data into your TensorFlow model, and it will not do the training. It will not do the BigQuery's part of creating a model, right? You have already created the model with the Adam optimizer. BigQuery will use that model to feed in data and train your model, right? So you can use the Adam optimizer, but when you are doing deep learning stuff with BigQuery, you have to keep in mind that there are some limitations on the maximum amount of iterations that you can run your model, and how much complex your model can be. There are some limitations to BigQuery for now. So you can view those in the BigQuery pages. So if you have a customized TensorFlow model, you can import that, and you can give the data, training data in, just like we did here. But first you have to upload your TensorFlow model to Google Cloud Storage bucket, and then upload that here. So I think I have answered that question, and so since there are no more questions, I would like to say again that we'll be sending a feedback form, and please fill that with your honest feedback on how we can improve doing these online sessions in this time of crisis. So thank you everyone for tuning in. I hope you guys have got something out of BigQuery and how you can do machine learning from BigQuery pretty much easily by knowing just SQL. So I will be sharing the slides in the Google GDG page with the stuff that I have written, the queries that I have written. I will be sharing them as well in the GDG page. Thank you everyone, and have a good night.
Thank you, Raveen.